So you've done it. You've fine-tuned a massive language model. It's become so easy to do this, right? But that ease, well, it's hiding a pretty big trap. Today, we're talking about the hidden dangers of shipping that model without putting it through its paces first. Let's get into it. I mean, picture this. You've put in the hours, you've run the training, and the outputs, they look fantastic. You've taken this powerful general-purpose model and you've made it your own. And man, that initial feeling of success is just awesome. It really feels like the hard part is over. You see those amazing results, and your first thought is, let's push to production. It works, right? But hold on a second. That gap between a model that just finished training and one that's actually ready for real people, it's probably a lot wider than you think.
This line just nails it. Putting an untested model out there isn't just a small risk. It's like finding out your brakes don't work while you're already flying down the highway. We're talking about the difference between a controlled lab experiment and a potential high-speed disaster.
So to really wrap our heads around this, let's use a better mental model. I want you to stop thinking about this like normal software coding. Instead, think of it like you're preparing a high-performance race car. This comparison really separates the two phases perfectly. See, training your model, that's like tuning a brand new engine on a dyno. You're just measuring its raw power in a super controlled setting. But testing, oh, that's everything else. That's checking the brakes, the fuel lines, the handling, all the stuff that makes sure the car is actually safe and reliable when it hits the real track. So how do we actually do this pre-race check on our model? Well, we can break down the whole process into 6 distinct testing lanes. And each lane answers a different critical question you have to ask before you go live. And here they are, our 6 lanes: functional, regression, performance, stress, comparative, and finally, quality. Think of this as your full pre-flight checklist for building confidence in your model, starting with the absolute basics and moving all the way to the super nuanced stuff. All right, let's jump into lane 1, which is the most fundamental test of them all: functional testing. The question here couldn't be simpler, but it's absolutely crucial. Does the model actually do the specific thing you trained it to do? And look, the key here is to go way beyond just a few spot checks. You need to run a solid batch of, say, 20 to 50 prompts that really look like what your users are going to throw at it. The big red flags to watch for aren't just wrong answers, but confidently wrong answers. You know, hallucinations. Or when the model just flat out ignores your formatting instructions. Okay, on to lane 2, regression. Here's the scary part. By making your model a specialist at one thing, you might have accidentally broken its ability to do something else. This is a real thing called catastrophic forgetting, and it's a really sneaky but serious problem. So to catch this, you basically have to pit your new model against the original base model using really general prompts. Did it forget how to do basic math? Or even worse, does it now try to reframe a simple math question as some kind of domain-specific advice? That is a huge red flag that your fine-tuning has gone too far. Okay, so your model is smart and it hasn't forgotten its ABCs, but is it actually usable in the real world? Lane 3, performance testing, gets real about the nitty-gritty of speed and stability. A brilliant model that's too slow is, well, it's useless. So here, you're measuring things like time to first token and how much memory it's eating up. You've got to make sure it's fast enough for a good user experience and has enough memory headroom to not crash. A classic red flag? A model that runs perfectly on your laptop, but constantly runs out of memory once you put it in a Docker container? Every system has a breaking point. The whole goal of lane 4 isn't to find every single weird edge case, but to understand how your model acts when it's under pressure and pushed to its absolute limits. This is where we throw all kinds of weird stuff at it. Empty prompts, prompts that are as long as the context window allows, even prompt injection attacks. You're not looking for perfection here. You're looking for what we call graceful degradation. Does it fail safely, or does it completely crash, get stuck in a loop, or let someone bypass all its safety features? Now, this lane is one of the most important, I think. So many teams make big decisions based on a gut feeling that a new version just seems better. Lane 5 is all about forcing you to be disciplined and use actual data. So here, you run these really rigorous identical tests comparing different versions side by side. Is your fine-tuned model really better than the original? Is that training checkpoint from hour 10 really an improvement over the one from hour 8? You have to document the trade-offs, because if a later checkpoint is actually performing worse, you need to know that before it gets anywhere near production. And here we are, the final and maybe the most crucial lane. A model can pass every single automated test we throw at it, for function, for performance, for stability, but it can still fail the ultimate test, human trust. This is where you need a human in the loop. A real person, ideally an expert in your field, scores the model's outputs using a structured checklist. They're looking for things that are really hard for machines to catch, like tone, relevance, and factual accuracy. And the biggest red flag of all, an answer that sounds incredibly fluent and confident, but is completely and utterly wrong. That kind of thing destroys user trust in a heartbeat. Okay, I know what you might be thinking. Looking at all 6 of these lanes can feel pretty overwhelming. But listen, the goal is not to be perfect from day one. The key is to be pragmatic and to right-size your testing strategy for where you are right now as a team or a company. This framework lays it out beautifully. It all comes down to your trust budget. Basically, how much room do you have to be wrong? If you're a scrappy startup with your hair on fire, your strategy is just don't embarrass us. You focus on lanes 1 and 4. Does it work and will it crash? As you grow, you move to a do-no-harm strategy, adding regression and performance tests. And for the big, high-stakes enterprise stuff, you need Six Sigma confidence. And that means running the whole suite, all 6 lanes. So no matter which lanes you're focusing on, there is one single principle that underpins everything. It is the absolute golden rule of reliable professional-grade model development. And here it is. This is what separates professional engineering from just hopeful guesswork. If you can't replay a test, if you can't compare it to a baseline, if you can't point to the exact conditions that caused a failure, you can't fix it. Every single test run has to be rigorously logged, the prompts, the model version, the hardware, the metrics, everything. And that brings us to the final and most important question you have to ask yourself. Because your model will break. That's not an if, it's a when. And having this disciplined approach to testing is what determines what you do next. It's the difference between panicked guessing and confident, informed operating.